Okay, good morning, everybody. I have to silence this. Where is it? So this is our last week of lessons. Today we have the last set of lectures, which is traditional construction, which is basically, I plan this as kind of review of things we saw. So we'll see examples of details and buildings in which you can see the application of many of the things we studied in previous lectures. Today we will have the West, like a European tradition, and on Friday I will give some examples from Korea. Also, it's not my specialty. I think it's nice to see both worlds. In the cover, you have Scotland's national monument, which is a copy of Parthenon. Again, interesting thing that they built it after defeat of Napoleon, the same as Parthenon was built after the defeat of the Persians in the Persian-Greek Wars. So before we start in the lecture, as I promised, we have one more detail to see. We'll have time tomorrow or Friday to have one more, so we are more prepared for the exam. And apologies for those who studied hard over the quiz, because we didn't have so much time today, so I didn't do it. We'll have a huge quiz next week, don't worry. So this is the tale of a wooden timber building. This was, of course, an exam example. I am looking for nice details for the exam on Tuesday. I hope it is a nice one. So the photos on top of the photos of this building, actually the detail is from this facade, right? It's important you have the image because that helps to identify the elements on the detail. This is exterior timber planks, you see. You have a deck outside. And the construction is cross-laminated timber panels, which is the photos below, which is not the same building, but it's just for you to remember what is cross-laminated timber in case you want to use it or in case that appears in the exam. And now things are tricky. Okay, just a bit loose the cable. So this is the detail, right? And just to start practicing, we have to identify the parts of the detail. And I don't say here what is outside and what is inside. And this is not as obvious as many of the details we see usually. So how can we, once we identify outside and inside, the rest is easy. But in that exam, about 1/3 had it wrong. And that messed all the things. So the first hint is the window, right? But this is a fixed window. We don't see how it opened. And this could be both inside and outside. We have a waterproofing in both sides. So this is also kind of ambiguous. So we have to see more hints. One which is probably, I don't know what's happening today with the cable. I didn't touch it. So we are used to see these planks outside with the buttons and ventilation space, right? Also, if this was the outside, this is very weird detail for a seal, in which you have the water very easy to come in, right? Besides, we have something which is pretty much with the slopes towards the outside as a deck, and we see something which looks like a floor heating. So I would bet this is interior and this is exterior, right? So the interior finishing layer should be number 2, right? And the exterior finishing layer should be, or protection layer should be number 10, which is the most outside. With that is easy because then plinth has not any problem. Plinth, the only element which is put into the bottom is 6. Ventilation layer, this is something we saw in other details. The ventilation layer includes the battens and that area, right? So it will be 9. 9 could be both support for the planks outside and the ventilation space, right? And the insulation can be only 4, right? So if you have the basics, it's not so hard to have 5 points in the exam in this case. Now let's go to the materials. And we have 10 elements. I didn't review it, so I hope there's not anything weird there. So let's go from the descriptions. And the first is insulating glass, right? Glued to stainless L 50 millimeters. Well, we don't need to see much, but there's only one place where we can have glass, right? And it is clearly put into L's. This is a fixed glass, interesting detail. So A is obviously 8, right? B, dripper in facade ventilation slits. So we see one slit for ventilation, another slit on the bottom, and one repeated number, which is at the tip. So I would bet the dripper is 5. Then we have 12.5 millimeters plasterboard white paint. We know the interior, right? So this will be the finish, which is number 2. You follow me? This is the only thing which can be plaster paint. Then we have 4-layer cross-laminated timber, 160 millimeters. This is clearly 4 layers of timber in 2 different directions. This is how often or commonly we draw the cross-laminated timber, right? 4 layers. So this will be the core, the thickest element, and probably number 1. Then we have 50 millimeters rigid fiberglass panel, which is obviously insulation. So I think that's number 4. We have battens and ventilation chamber. These we already identified in the question before, which is 9. Hello, Pali Pali. You missed the quiz. Okay, then we have 190 millimeters. If you have it out, the dimensions always give you a hint of what to look at, right? Precast concrete anchored to foundations. The only element which looks like concrete here is the one in the bottom, right? Which is number 6. So I would go to number 6. For this, yeah, number 6. Then 20 millimeters cedar planks, black stem finish. We saw the photo, and that looks like the protection. So that with the exterior layer, probably number 10, right? The planks. Then we have a 25, 38, 33 pine battens framing vertical, horizontal for exterior layer support. And this is some element I was not careful putting the numbers. That is repeated, should be again 9, right? Because both the battens for the support of the exterior layer and the ventilation chamber, right? So if I'm not wrong, that's again 9. We have the solution later. So then we have a SPS bitumen waterproof. That is easy. Where do you have waterproof? I think we have here, right, at 7. And we have only the vapor barrier layer, which is next to the insulation is number 3, right? So in this case, it was important. We were very aware of what is inside and what is outside. And in that case, the photo of the building really helped. For the exam on Tuesday, we will try to have better prints, so the photos are not as messy as in the midterm exam. That's it. That gives you 15 points in one exam. And it's, so you can tell me, yes, actually, I just repeated one element there. Okay, so let's go into the traditional construction, first part. And are you too busy? So first, we have to define what is traditional construction, which is not as obvious as it seems. In the photo is probably traditional building. That's the National Museum of Scotland again. This lecture is very Scottish and very French. So probably most general definition is the construction techniques, construction technologies developed through centuries of trial and error, right? This is what we call traditional construction. And this is what people learn how to do or know how to do before we had the schools, universities, and so on, which is improved and transmitted generation after generation. But we call also the construction techniques previous to steel and concrete, right? Which is obviously over 100 years. So it's steel and concrete is not so modern anymore. And also the ancestral typologies like hanok, temples, and so on, which have traditional materials and traditional techniques, right? So these are 3 different definitions. And here, I think we refer to all of 3, but it is not always the same. The second question, this is not exam question, so don't worry, just to give some context. Why we should study or be aware of about traditional construction? Well, there's several reasons. I can think about 3 mostly. First, well, this is here in Seoul, Myeongyundang, the old Confucian school, which is originally 14th century building. So that needs to be repaired, maintained. And the people who do that have to know very well all those techniques, right? You cannot do it in a modern way, or you can do it with many limitations. So just to keep our traditional buildings alive, we need to be aware of those techniques. Even for renovation, this is the old lecture halls next to SK Future Hall here in Kodae. This is more modern building, but you see the hard time the architects had to maintain the old structure and to add a new structure inside it, right? I'm not sure this is the best example, but this is very realistic thing of how we have to, or the problems we have approaching the preservation and reuse of old buildings. Second, this is the Göteborg or Göteborg City Hall extension in Sweden, right? The old building on the left, new building by Asplund on the right. And actually that included a lot of changes in the old building. So just to renew and to expand buildings, even using new techniques, you have to be very careful and know how much you can do in an old structure. So you don't create more damage than benefit there, right? So the new building has totally new technology, but the space in between and the things you change there are a very ambiguous point, as it happened in the previous example in the Kodae lecture halls. And third, this is one of, not so recent now, but one of those prizes to young architects doing innovative architecture in developing countries, right? that means that we can use traditional technologies in new ways and be modern without need to have always glass, steel, and concrete, right? And this is one point which helps us to understand how important it is to really understand the benefits and the possibilities of all techniques, all technologies, which still can be used and be beneficial in many ways. And there's one additional reason. I don't know if you recognize this. This is one of the most famous spots in Korea. Hahoe Maul, of course, not the real one. This is the visitor center at the entrance, which is a commendable effort to keep the harmony and the construction, but just weird things like this kind of glass door at the entrance, right? That's not the main issue, so I would think it's not a great idea. But when the same building has this back, I suspect a lack of sensitivity and knowledge. It looks like a building designed by artificial intelligence, not by a human being, right? So not just knowing the technique, but being aware and having that internalized as one of the design choices may make a much better decision in this case, right? So we have to avoid those things when we make buildings. Actually, most traditional villages have been mostly spoiled by becoming tourist theme parks. It's kind of pitiful. Those who knew those villages in the 1980s, right, and go now afterwards, it is nice people still live there, but things are lost there. I'm not so positive about this. Okay, so basically 3 ideas, and also to be sensitive on how to reproduce or replicate today those old models. And then there's one question: which are those basic traditional construction techniques or archetypes? Then we go to lecture 1, which I will not repeat, right? So we go back to the beginning. And basically, we can say this is a massive construction and the light construction. And as we saw many times, there are traditions which are more on one side than the other, but often they are mixed in some way, but this is the beginning. So European architecture is mostly earthwork, not only. This is why you have so many massive stone buildings remaining, whereas the Eastern architecture, and I give the example of the Korean, is mainly roof work, timber, and this is why it's so hard to have so many remainings of old buildings. And now we have to go to the typologies, right? So we have the monumental, which is the ones we usually study, which are palaces, say Gyeongbokgung or Cheondeokgung and that, religious and funeral buildings, cathedrals, temples, and so on, and military buildings, castles mostly. But we have the domestic, and it is often forgotten. And the domestic is probably the least preserved, because it is easy for a castle to remain and to be preserved, but not small houses. But domestic makes like 90% or 99% of the real construction, real use. So for us to understand the city, not only buildings, domestic architecture is important, right? And to know how traditional houses are made is important, as well as schools and so on. So let's go into Europe. And this is the city of Avila in Spain. It's one of the most well-preserved medieval centers in which the city grew inside the Roman wall, right? So it's the wall of the Romans, of course, many times renewed. And curiously, the cathedral is integrated, is part of that Roman wall. So it's kind of fortress church inside. So how do we gather the knowledge from the tradition? So the first thing is the remainings, right? Most important. That's the archaeology. The photo is the Caracalla Thermae. This is the baths in Rome. So having so many massive stone brick monuments made it easy to have so many remains which have been studied, right? And you gather the data, so you know the design, the proportions, the construction. You can also identify the way of life, but also the construction techniques. Second, of course, inherited technologies. Many of those techniques from the Romans and before are still used. This is one example of Spain, this kind of remember we spoke about the thin bricks with gypsum mortar, which dries instantly. So you can make on the fly just 1 volt without any kind of support, right? And this is one technique which is still it's almost lost in Spain, but this is the north of Africa and the Mid East still use it, right? And since people keep doing that, we know how to do it. And of course, then we have the books. Unfortunately, we have quite a wealth of treatises. Most all this Vitruvius we said before. So you look at over 2,000 years of written information, which is really helpful, and which is used to have all these informations. So like 3 sources, all 3 very rich and quite wide. Today we have like just almost a final lecture, so we will concentrate mostly on the books, right? This could be a full, not a full course, but a full major. Actually, there are majors just for traditional construction and traditional buildings. So the oldest, it's Vitruvius, 1st century. Most influential in the West has been Palladius for books, which is 1,500 years later, a bit more. Maybe not the best, but clear and really influential. And then when we go into the modern architecture, I chose Viollet-le-Duc because he's one of those people who really was in between the tradition and the starting of the rational scientific neoconstruction, right? So he has a very good bridge. And I chose one of his publications. He wrote a lot, he published a lot, but he did a very beautiful small book on how one house is built, right? With all the details. So it's a good example of a traditional construction, but also a very good graphic ability those guys had. This is taken from a first lecture also. Remember, we had like Kenneth Frampton is the guy who took from Semper the idea of earthwork and roof work and repeat on the book. Semper is a German architect, same as Viollet-le-Duc. He tried to understand the tradition and to bring the path of bridge to new architecture. And then Viollet-le-Duc, which is more or less same, but a French version. Seems I'm not German speaking, I'm much more familiar with Viollet-le-Duc. This is why I chose the second one. I will insist, so Vitruvius in his 10 books speaks of the materials, construction. We already commented on that, so we don't need to repeat. Only just remember that there is the same materials we studied except for steel, glass, and not even concrete, just reinforced concrete, right? Because they use concrete already. And actually, illustrations tell about the ways of building. Only thing which is interesting, which you see here, that Roman bricks started being like a really big, like a square shapes, right? Not the rectangular ones we have. Also, they had also the rectangular version later, which is a bit more practical for construction. Which are the ways of construction with the concrete and mixed concrete and stone. The stone only for cladding outside, and the Greek way of using stone with a less careful stone inside, right? Remember, we saw examples of cheap timber inside in sachets and expensive timber outside. This is the same, but with the stone, right? So this kind of economizing the materials is kind of tradition which remains today. Let's go to Palladio. We'll go fast into that, just because Palladio was so influential in all Europe, the UK, and UK brought it to the Americas, the States, and Australia, and so on. So there's so much about it. So of the books, again, in the first book, same as Vitruvius speaks of the techniques of construction, right? And he refers to Vitruvius. So again, the ways of putting the bricks in a kind of geometrical pattern, of which still we have remainings from Rome. The brick filled inside with stone, right, to economize, which still is most of the construction we have from the monumental buildings. The opus incertum, in which what we call the rubble, right, not geometrical use of stone. In this case, they have bricks in the borders and in between to give more stability, to close the corners, and to have a stronger fabric. Curiously, this is the construction which still remains in some areas of Spain. This is the city of Toledo in central Spain. And this is that Roman way of construction, which is still, for some reason, became very successful, and it's kind of their identity in construction. And then opus incertum, or what we call the rubble, in which you see always there's the care to have a clean stones on the corners. Corners are always something which people are careful about. It's an example of that. And then this is, well, that's the rubble, right? Then all courses equal, and the concrete wall, right? We have a concrete, which again, this is Palladio describing Roman concrete construction, right? Which is the same as we do today, only they didn't reinforce it with steel. And coming to this point, I have one question for you. Do you remember the three basic components of old concrete before Portland cement was invented? You know what usual concrete is made of, right? Only one ingredient is different. I give you a big hint. Portland cement is not. What did they use instead of Portland? And then what did they add into it? I'm not sure we will ask this in the final exam, but if I don't forget, I will comment on Friday. There's one more question later in the lecture, which maybe is easier to reply. Okay, it seems we have all weak memory. Write something, even if you don't know. Okay, then we have the Greek style, in which we have like transversal connections, right? And so on. Then Palladio spends a lot of time explaining the vault construction. He doesn't give construction details because, again, it is assumed the artisans know how to do it, but he explains the geometry mostly. Right? So just the geometry in terms of proportions and the thickness of the walls, just to have the proper proportion and stability. But curiously, it is supposed that with a previous description of the walls, artisans will be able to build them in some way. I bring those drawings just to show the idea. This is construction drawings, but actually this is like the design, right, section. Remember we spoke about it when we made it, sections. It is showing the space with shades and some. Construction is just white. He doesn't worry to put the stones and the layers because it is assumed people already know how to do it. And then the drawing is very clear, right? One thing which is interesting, you will note that most traditional buildings, the thickness in relation to the height is about 1/8 to 1/10, right? Which is very basic proportion. This is just because of the buckling of the structure for stability. And then he speaks about door and window proportions. This is for design, but also for stability. So to have not too much openings, so the fabric is solid enough. And then chimneys, we will not go into it. Interesting thing, and instead the design. So chimneys is what we have now, like a environmental control systems, right? Windows to let ventilation to have lights and the air, and then chimneys to have the heating. So it's very, very complete treaty. I will stop a little bit on stair, because I found that Korea is very weak on stair design and construction, even today. And then, of course, we have roof design. So this is one example of a Palladian stair. You will see many of those stairs in American and British Palladian books. Again, see the section, right? No description of the inside of the walls, but curiously you have the description of the timber structure of the ceilings. This just to show how beautifully it is done. One thing that all classics tell is that monumental stair has a small angle, right? Usually we have like a 30 degrees, it's like the basic comfortable stair. This is much softer. So monumental stairs, the lower you do them, they are easier to climb, which makes the building more accessible, because accessibility is not only ramps, it's the stairs being able to be used by other people, but also small slope will make stairs much more pleasant and monumental in some sense. And this about roofs. See how even if he's not explaining the construction, the roofs are always explained in some way, right? This is another example in which you have the section in this area, right? Different way of putting roofs. And again, this is very reasonable. You don't need to be an engineer to understand the logic of being economic, simple, and using a combination of roofs and bearing walls to have a logic structure inside. So let's go to the pre-modern period. Viollet-le-Duc, 1814 to 1879. Quite a scary guy, hardworking and really intelligent. He did a lot of work of analyzing all the buildings, historical buildings in France. He was really in love with Gothic architecture. After all the years, people so concentrated on Roman architecture, Greek architecture, Palladian architecture, he saw that Gothic was much more scientific, rational, and he really tried to understand that, well, actually, he worked in many restorations. Notre Dame, he was able to stabilize the church. That gave him a lot of information how it was done. And then he tried to combine those medieval techniques with new technology like steel, right, and concrete and so on. So this is very much in the point of what is the reason for having this kind of lecture, or this kind of study of the traditional construction, right? Because there's many things to learn from those old architectures. And many people consider him, as we can have with Semper and other guys, like the people who really started to think in a modern way, the fathers or the grandfathers of the modern architecture. I brought just some examples just to show you how truthful and how beautifully he did the drawings of the buildings he studied, he analyzed, right? This is one of it, just at the exterior view. The very painful but very precise description of the framing of timber of traditional houses and Gothic buildings. Again, you see this is very much well done. This is a design section, no details inside, but the proportions of the walls and the space are correct, right? So this is done with already a knowledge on how things work. So let's go into how to build one house. One building published in 1873, so 150 years ago, which is amazing. This is a small book just for the general public, for people to understand what is the work of the architect, how this built. And this is written in the way of a dialogue between a master and the pupil. telling him how things are and what is the logic of the construction. So the story is a family in the countryside. We have the old castle, right? The Vieux Chateau. And that's all this inconvenient. It has no light, no ventilation, and they would have to make a modern house. So they make a very modern building, which is partially traditional, but it's reasonable. You see, we have the north, right? So the rooms are mostly southwest. The working rooms are mostly northeast. There is not so much a big expanse. There is a link between service and living areas, right? It's usually the kitchen, courtyards. This is some landscape, and always rooms have at least 2 or 3 different orientations to have plenty of sunshine. So it was the revolution, and they have bathrooms, and the rooms are huge. This is the bed, right? So the concept of scale is different as today, but this is a modern house in 1870, right? This idea of the roof, just to show you that we have to be aware of the geometry of roofs and to understand how they are done. And see here the pane done to avoid having this kind of a valley between many roofs, so the water does not accumulate, it has an exit at some point, right? This is from the foundations. This is a drawing we saw already in the plinth lecture, just to show how the water coming from the mountain can be diverted by a kind of conduction. Now we do it in a much more subtle way. About the foundations, this is a very simple diagram, but telling that one building should be supported always in the same kind of terrain. If you're not careful, this will be eventually tilt and have cracks, right? This is a very silly thing, but even today, many people fail to do this. And for some reason, Korean clients do not want to spend their money on geological surveys, which are very cheap, and they end having much more painful reparations with that. The excavation of the basement. Remember, we saw you, for one small basement, you have to excavate it more than you need to have some space to work and to do the other side of the wall. And then the vaults. In this case, you have the vault to create the floor. So why a vault here? Because you have a lot of strength from a lot of pressure from the land, from the ground. So the vault will make kind of counterweight and help balance it, right? And then this will be filled. Usually it was done with ashes, light elements to have just the floor on top of it. See the proportion of the thickness of the wall. This is a basement wall which is stabilized. Usually in retention walls, which are done by gravity, usually the height and the thickness on the bottom is almost 1-to-1, the proportion. In this case, which has a kind of vault, the proportion is probably H to H, probably 1-to-2 to 1-to-3, right? And this is one detail. That's the power of the axonometrics, right? This is showing all the inside, the construction process and people inside. So we see very clearly how the construction is done. And here you see that thick element, which is probably 1-to-2, the proportion for the basement. And then on the upper floors, it goes diminishing, but it will be between 1-to-8, 1-to-4. Well, curious design for the stairs. And then problems he encountered in traditional buildings, and he tried to correct here. What is the problem here? If you have the same wall, load-bearing wall with a big floor, right? Even if you have some supports, this moment will create deflections on the wall and cracks, or will make the wall just to lose the vertical because of floor pulling. So he just said, if you just make a thinner wall, right, on the top with a rigid element, this element will have a contracting the moment. This small difference on the strengths will just counterweight and make the building more balanced. So this is the putting the physics into the service of making a better detailing. Roof frames. Again, there's something that I have a hard time to put in your mind. Is the need to have the full element before you show the details, so we know where the details are. One detail isolated says nothing, right? But when you have the full element and the details, you understand instantly what is it about and what's the importance of it. What is interesting here is the assembly using the minimum of nails, right? There's all carpentry, which is just the assembly without relying on the nails or metallic elements. Then the wood basics. And then this is something which is familiar, right? Those people have to use a lot of timber. So even for a general public book, the timber cutting and the timber problems were explained. And he explains the half a cut of a timber. If you let it dry, it will bend it this way. Yes, why? Why? Is that it? Because it is the fibers of the rings which shrink, and you have more fibers on that side than the inside, right? So that it will pull more. Also, the longitudinal is not so extreme as the transversal element. In a very long element, that will happen. So, and since in the roofs and in construction we need many long elements, it's interesting to be aware of that. Construction of the roof, again, the power of axonometric. Axonometric is explained a lot. And this is beautiful because you see the full process of how it is made, right? From the rafters to the purlins and to the slates. And curiously, this is exactly the same detail we saw in class. We built slate roofs the same as 100 or 200 years ago. Other interesting thing is this part. You see this kind of stone cornice topping of the wall, which may be stone or brick. Those two elements are, I don't know the English name, I should have checked. If we translate from Spanish, it's dormants, right? Because they're really not making any work, they're just transmitting the work. So these are just isolating the main structure from the wall. So you have a ventilation, right? You have less contact. So the humidity from the walls will not affect the timber. Always when we use timber for interior, for structure, we try to isolate from fabric, from bricks, from concrete. So the humidity will not affect it so much. The second is to have this kind of long element just to cover the thickness of the wall, right? Always the wooden structures in those buildings have some kind of device to adapt to that wall thickness. This is tricks to counteract this kind of deformations we saw before when we making the construction, and then tricks to have this kind of, well, easy to build but well designed structure. Then we start, this is like the basics to understand how buildings are made. Now it is the project and the construction process. First thing is the basement plan. We always build from the basement. So this is the one plan we always have to make, and it's most important because any error here will affect everywhere else. And you see you have names for the basic points, the arcs of the vaults, as Pallido said, and then the axes. They will have labels, right? A, B, C, whatever, 1, 2, 3. We do this always, and we need to know the basic structural lines. And this is all structural lines, right? For the openings or for the walls. Because this is the reference for the full construction on the vertical, for the calculations and so on. Of course, this is not real construction drawing, so you don't have dimensions and things like that, but this is what you are supposed to do. And on the back, you see the drainage on the back to take the water, right? Which in this case is a full channel. Then the construction on site. As we saw in previous lecture, we have to draw the building on the floor, right? And we start by putting the axes. And then with strings, we can have the position very precise to the centimeter or less than 1 centimeter. And then with supports, in which you can just recover those lines when we need them. And then you see literally the building, the walls are drawn so they can start to be built. This is one detail of those elements, right? And this still we do today like that. Sometimes we can use laser to have more precise measurements, but then those strings, like 3-4 millimeters thick, right? I have to put them by hand. So it is totally unrealistic to think the 1 millimeter precision will happen in the construction site. Maybe in Japan sometimes, or in Switzerland sometimes, but not in the rest of the world. And then this is traditional construction. So on the foundation, you put the frames to build the bolts, the windows for the basement. This is the ground level. So just to bring light and ventilation to the basement area. I brought this just to show you the complication of detailing when you make things on stone, because you have to make the precise cut and you have to define the stone shape for it to be cut. Even with Rhino, you have a hard time to make the perfect definition of each of the pieces. Right? This is how it looks when inside in construction. And then the detail of the walls, which is very much what we saw with Palladio and Vitruvius before. Very careful stone on the outside and rubble inside. So you have the mass you need, the stability, but you only spend on the front of the building. Then we have the full elevation. And again, when you make a facade detail, a window detail, whatever, we need to have the context of the full facade, right? We always start from the full building. And this is, again, the modern building with the greenhouses, plenty of light and ventilation and so on. Again, the care for the corners. In all buildings, corners are difficult, not only in curtain walls. And this is why they have like a special, more solid construction there. Then we have the window. Again, the beauty of the axonometric, right? So you see not only the section, but how things look in reality. If you have a basic ability to make a construction section, you just add a few lines. Your design studio professors will be so happy. And all clients and the competition guys will be so amazed at the ability. And this is just maybe 20% more of work. But more important than that, you will see really the reality of what you are doing, right? It's not abstract anymore. See, the top is not just aesthetics. Of course, this is kind of Gothic-based detail, but this is like important repair, right? To start protecting from water the window. Same happens under, and the seal with a good slope. And then see how the fabric is made in a way to protect as much as possible the fabric. This is the outside, this is the inside. So the fabric is always protecting, covering as much as possible of the window, right? And there's the counter windows, again, which are designed in a way which can be totally folded. The shaders, which can be folded on the side. Again, this is all the school, but really sophisticated design of a window, right? I wish we have this kind of nice shaders in Windows today. Well, this is an interesting idea. I think this is a Villaelitic on thinking to put the beams in diagonal, so there will be support for the mini walls to support the floor. That's kind of being rationalistic, kind of innovative, but I cannot say if this is invention or if he copied from somewhere else. Because detailing, always in context, and then the construction goes up. This is a moment which is always important in construction, the moment you reach the ground floor level, right? You see the back of the vaults, and you see a lot of passerelles and people working around. I will increase this. It's a full workshop outside. Nowadays, we bring many more things already prepared to the construction site, but in any construction, we need a lot of space, right? For storage or for working. And that space for working means to have organization, to tell people where they can work and so on. If you're going to construction management in a construction company, you will be spending a lot of time planning for this use of the space for storage, for preparing things, and to move around. Also see the passerelles to move around. The possibility of people to move safely on the construction site is something that is today also kind of nightmare in a construction site. And it's very well depicted here in that small illustration. Then this looks very obvious, but how you cut the stone? You have to cut the stones with a small cut to the outside, so you don't have sharp edges. So the mortar will fit in and will not break. If you have sharp edges, they will most likely break. We don't make this kind of walls very often, but you'll see with just a small stone slabs in stairs and other places in which they reach a corner and they make kind of acute cut, and that breaks very often, right? Or you have a corner in which you have the two pieces of stone put together, right? And they break. These details happen even in Herzog de Meuron, right? Not because they are useless, because they're just so small details that somebody does them without anybody supervising. And there's something that already Viollet was warning us about. Very careful about cutting too much stones. Stones are fragile, and those very sharp edges cuts do not work very well. That is what we spoke of stereotomy, right? The three-dimensional drawing of the stones. And for that small house, this should be done for every stone detail, and it had a lot. So it could be sheets and sheets of each stone cutting, so the quarry would impress precisely what they needed. Then stair design. This is a beautiful drawing of a traditional stair. Two things to comment here. One is the drawing of the stairs in section, putting all steps equal, the same height and the same length. This is something that 95% or 19% of stairs in Korea do not respect. You have always the first or last step is different. In Spain, for example, plus minus 2 millimeters or 3 millimeters is against the law, right? Because our muscle memory is so precise. When we walk, we just have a sensitivity of 2-3 millimeters. You have something over the floor, you just stick it, right? The lazy walking, really, we almost do not raise the feet from the floor, right? And then when you climb a stair, after 2 steps, your body knows how to find the following one. If you change 1 centimeter, you lose your step. There's so many accidents in stairs. Death by accident at home is one of the most common causes of death. Within home accidents is electricity shock and falling downstairs. And so first thing to do it is to draw them carefully. But when we build them, we do the same in the construction. We draw the steps on the wall and we make steps. We make sure they are in the proper place. And then again, 1 millimeter or 2 can go out, but you have to be precise. The other thing is when you have a rotating stairs, let me see if we can go to the next line. Well, this is the idea of having it equal, right? You see that the steps are not concentrical, so they're not getting a radius and putting them as we do always with Rhino, AutoCAD, or Revit, right? Because these are very hard to climb. This is what we call compensated or compensed. I don't know what's the proper term. Or compensed steps, right? In which we try to make the narrower parts to a minimum. Usually like a 19 to 20 centimeters. You can go to 15. So you can always put your foot. So what you do is you divide the interior part, and then you divide the exterior part, and then they are eccentric, but you try to have during the rotation always the same width in the interior part, right? There's plenty of geometrical devices to do that. Again, traditional schools used a lot of time in those things. Now we expect the software to do it for us, but I don't know of any intelligence software that's able to do that properly. but it's interesting thing in this part, right? So you see how they start compensating the steps much before the corner, right? That makes much more safe, much more comfortable stair to climb. One interesting detail for steps, cantilever steps, if you have the space for that. And then the section. And see, we have a full facade, full elevation, and we have full section of the facade. And then we can go into the details. The corner, of course, the windows with the roof, the plinth, and the details. Always you have to use the 3 scales, full building, section, and the details. You have the context. Because if you have only this detail, it's very hard to understand how it works, the logic, and how we integrate in the building. So basic dimensions. Welcome, nice to see you. And then you just give basic dimensions, right? Again, see not only the decoration, but this kind of elements which will give shades and provide some kind of a volume depth to the facade, but take the water away from the surfaces and the windows as much as possible, right? These dripping elements. And of course, you have the English window and the French window. If you didn't know, this is a French window. Will not be the exam, but I didn't know until I read it. And then again, the molding of whites. This is interesting because this is not for construction, it's for aesthetics. So molding should be done in a way that you can see them. If they give shade to each other, they will not have volume. So they have to make them in a way that you will see the light and the shades, so they give volume to the facade. This is interesting because I remember my professors, oldest professors, who studied in the 1920s, right? They spent months and years just drawing moldings, memorizing and drawing the light. And they used to say, you're so lucky you need to draw that, right? And actually the drawings were like amazing. The photographs don't just watery ink. But well, that's important to have this kind of a visual impression of the facade with a light on it. And then we have the full building. Again, beautiful, it's kind of a manhua-like drawing. Again, design section, as in Palladio, they show the frames of the roofs, but they don't show the construction of the walls and all the life inside, right? All the interior space. Again, roof framing. This is interesting because this is a roof structure, but instead of throwing all frames one by one, they just give one key for each frame. So you refer to it in the details, as we saw in the construction management, right, drawings. So just give the main plan and then just the keywords to find the special elements. And here you have one of the frames. This again, still a bit Gothic-ish, right? So you have like 2 attics. Remember this habit in France to not account the space over the roof, so you can try to have as many attics as you can. And then using the perspective only in very complex details when you need to explain something special, right? It's not a general thing. Always you start from the elevation section and then axonometrics perspectives only when things are complex enough. But you also start from the basic section element. Very seldom we start designing in 3-dimensional elements. All this detailing consistent with the basic ideas they showed before. I don't need to explain this anymore. For example, the technique of cutting the timber. This is something which we saw already in our lectures before. And then the window detail. Windows are important, right? I cannot say it enough. And this is a pity when we make a project, we spend so much time in the floor plan, in many things, and then the elevations are just the typical window from the catalog from the market. Even this is a very plain window, right? The specifics of the windows are so unique and so important that I think it's worth to spend some time in making them properly. Of course, this is a full set. This is a dormer window. You see the line of the roof behind. This is the channel connection between the roof layers or roof plans. This is the full elevation, right? So door, again, in old days, doors were made on site. I have to detail them. This was done just until the generation before me. So when I started, I almost always use the catalog doors. but it's interesting to know how they are made and the progress. Actually, you need always to have the frame, the door sheet, and then one element to cover, right? One frame to cover these slits. And then if you have the total detail, the elevation and the section, then the large scale detail is in context, it's very easy to understand. Now we go to the window. And we are close to one of the elements we studied in class and the things we can have in the exams. So full elevation. Remember, this is old house, so the sheets of glass are small, but it's quite large for that period. This is two sheets window. In the France tradition, we would draw the opening like this with a hinge on that side, right? And this is the plan. So this is the horizontal section of the window. See things we already studied. The fabric always protecting as much as possible the frame of the window, right? They don't explain how it is done, but it will be fixed to the wall. See the trim just to cover those slits. Again, overlapping is traditional. There was not silicone back then. And then the window detail is interesting because they have kind of, this is Viollet-le-Duc idea. They didn't put a decompression chamber, but they did some kind of a complicated connection. So the window can open, but it still will block much more the air and the water. And same happens in the connection of both windows. So this detail was tested for the windows to be able to open and close. And curiously, you see the glass is put on the outside. I think we commented this before, right? And connected just with the small nails and small plaster. This is just for the idea of the glass protecting a bit more the timber and getting the water outside. Right. Nowadays, we put almost always the glass from the inside. And this is the section. And again, if we see this detail, I don't need to explain anymore because this is familiar already, right? We are able to identify all the elements there. And this is probably the most complicated detail of this window. And then this is the assembly elements. Again, three-dimensional. Within the context, you see the intermediate elements. Again, the wood is cut in those borders. Why did they do that? It's not only for decoration. It is because those borders usually suffer, have marks, they break. So if you have a small cut, it will be much more easy to maintain, not only for visually, for being visually pleasant, right? Sharp edges always suffer, always have how do you say, marks and bumps and so on. So see, we have the seal, right? Because this seal, we have the full window, so we know it's much longer. You have the trim to cover the space between the frame and the seal itself. And then we have two elements, which will be the following question. So now we have this small window frame. Remember, this is the seal, which will continue until the dripper. This is a stone, right? We have the frame, we have the sash, we have the trim, and there's like three elements I notate, which I invite you to identify, to remember their names and say what they are. Because this is a possible exam question. We can have any other window, and you have to identify or analyze what you see there. And I think it should be easy. If you did the window assignment, you came to class and you understood it. Yes? So remember, don't remember, already forgot? You remember? May I? You can speak, right? You can shout, you can sing. Okay, that's easy. So this is to see how basic the window, the SAS design is, right? This is a simple one, but quite interesting for that time. See again the logic of the glass outside. Oh gosh. I think the cable is tired also. He's huffing with the holidays. So I would try to touch much, but see the glass, right? With this kind of small things, probably one nail there. So the glass is giving more, letting the water to stay out to protect more the sash itself, right? Nowadays, as I said, we put often the glass inside. And then curiously, the dripper is additional piece. Could be done on one piece, but probably this is just an addition to the sash, which is more or less the same in 4 sides. So they don't need to make a special piece for that. And that element here is part of the hardware, right? This is metal element to have the opening and closing of the window. We have the detail of the roof. And again, this is so familiar, right? As we said before, we see it here in detail. Probably the slates are a bit thinner and longer. But what is important here that we already studied? You see, this is a very steep roof, but even in that case, Violleduc is using like 3 overlaps, right? 3 layers of slate. This is very, very traditional and very safe to do always. And in this case, the slates are not nailed directly, are put with just hooks, right? Which is also a very common way of doing. I wouldn't say what is better. In my house, I have hooks. And after 20 years, they're starting to rust, even though they are galvanized. It's not nice. If they had nails, other slates will cover that, and probably that still would be not rotten, right? But with the nails, you break the slates and you perforate, so they are more fragile. So I have to say, I have broken tiles also with the time. So this is a choice that is not always clear. And see here how refined they are to cut the pattern so the slates are perfectly parallel. I never saw this nowadays, right? But it's telling you how careful were all these artisans doing their details. And then we have the ridge, as we saw in class also, is usually made with metal. This is probably thought on zinc and with seamed elements. Hard to see, but they're like really, really strongly rolled together, right? To create that topping. So that seaming is a bit exaggerated, but mostly the same we saw in class. The same with the gutters, right? The gutter which has a lot of seamings, even a dripper over there. Again, we are not so complicated nowadays, but in 1870, that was like a very simple and very modern economical way of doing things. And then the house finished and ends with the opening party. So you see the book is telling a lot of things. First, you need to know the basics. That was the first slides. Then you need to plan the house, and then you have to build it, right? And the building process is something you have to be very aware to be able to make correct details. And we will start from the foundation and end for the roof, mostly in general. So this is quite instructional. And then the details are very realistic and very good ones, right? So we could see application of the old days of the details, many details similar to the ones we studied in class. So I think it's quite interesting practice in that sense. And that said, that was imaginary house. I just brought a British house. But this is Lothians. It's British architect, contemporary Le Corbusier, but who never embraced modernism, but he has fantastic houses whenever you can visit them. This is the only house he has in Scotland, but he has many in Britain and India, right? He was the one who designed the government center in New Delhi and the plan of the city. And again, this is not slate, this is tiles, but basically the construction and the detailing is very similar to the one we saw before. Also, French and British have a small differences in how they approach the design, including this kind of rotary at the entrance of the house. See how you don't need asphalt? Just a well-planned gravel access is much more pleasant. Of course, still they use horses there, and asphalt is not great for horse riding, but still in a rainy place, you don't need asphalt always in the gardens. So that ends this lecture. Again, on Friday, we'll have the final one with your questions and answers and comments on activities. Just a reminder, because everything is said already, please review or study or go into much as you can of the lectures from midterm, because we have an exam on Tuesday next week. I cannot do it much later. This is the last day we have. I just previewed. The assignment 10, I checked yesterday, and I'm not sure it was open or not. It was really programmed to be opened. Yesterday night, nobody had done it, but you can do it. It will help for the exam. And again, that assignment 10 is volunteer, right? So that will add points. And many of you are very much in the limit. So it's not that 8 here. In the limit of 8 or 8+, but in limit to F to E+. Passing is important. Alternative assignments, please submit if you can today. If not, I will not be able to review them on time. And the missing assignments, you can submit until Tuesday, but from today on, I will not return them, right? Because I don't have time to review them. Time is already over. But again, many of you, I know it's busy, but the assignments were not so difficult or so time consuming. They give you a lot of points, right? Assignments are much more heavy in terms of evaluation than the quizzes, for example, because they're more practical and I think more useful. And since the grades in assignments are much better than in the quizzes, I think that makes sense. But if you don't submit assignments, then that's a problem because you're relying mostly on the exam. Of course, you can pass only with the exam, but it's a pity you take risks there. So, okay, I know it's just 1 week to finish the semester, so it's not easy to deal with everything. And that's it. If you have any question or comment, please write it. This is the last day I can return the sheets, so your last chance to ask whatever you wanted to ask, but never dared to. I will be happy to see your questions and comments, and we'll reply then on Friday. That's it. We're finished for today. One thing, you may have noticed that the school is blocking the Google accounts because of the extra memory. So I might not receive your emails if you submit them to the school. And I'm not always able to access the YouTube channel to upload the videos, right? So I put the channels in open so you can access them with the link, so you can see the videos, but I'm not able to add new videos or no until I have to do every 3 days because I have so much memory from assignments and the team drive and so on that school was very kind, planning to block the accounts just at the end of the semester instead of doing it in the summer vacation. But there's something you have to communicate with me. Just remember the school email is not reliable. I can give you just my personal email. You can take a note if you want. If you want to communicate, right, that's a safe one. We have another Gmail account from the department, but we found it is linked to the school, even though we pay for it, and we have to unlink it, and it's a complication, which is great to deal in busy times. Anyhow, thank you so much for your attendance today. See you Friday.